What's happening, guys? Mr. Allen here, and we are about to graph. This is dope. Quadratic inequality. Okay, this is getting crazy. It's gonna get crazy. Starts out the same as just graphing a normal quadratic equation. I want to find my vertex first. If it's here in standard form, it's gonna take a little bit of work, but that's okay. So I'm gonna have x equals, and the opposite of b would be positive 8 divided by 2 times a. So this is going to equal, well, 8 divided by negative 4 is going to be negative 2. So that's my x-coordinate of the vertex and also my axis of symmetry if we choose to graph that. Main thing we want to graph is the graph of our parabola with like 5 points and get our shading down. Those are the general requirements for graphing quadratic inequalities. X-intercepts and y-intercepts, not necessary to write them down, but we can. All right, to get my y-coordinate, I'm going to need to plug that negative 2 back in and evaluate it. So I have negative 2 parentheses negative 2 squared minus 8 times negative 2 plus 1. Negative 2 squared is 4. 4 times negative 2 is negative 8. So I have negative 8 right here. And then we have plus 16 plus 1. So that's going to be 8 plus 1 is 9. Whew. It's a bit of work when you got that lead coefficient. So I have negative 2 comma positive 9. It's way the heck up here. Now I'm going to figure out some other points here. Why don't I plug a point into the right of that? So how about negative 1? We can even have a little t-chart if you prefer to figure this out. So I've got my vertex, which is negative 2 comma 9. I could plug in negative 1 and 0 for my other values. And then I could do the negative 3 and the negative 4 here, but they're going to be the same on either side of that vertex. So negative 1 getting plugged in, well, that's going to be negative 1 squared is 1 times negative 2 is negative 2. Then it's negative 2 plus 8, right? Because negative 8 times negative 1 is positive 8. So negative 2 plus 8 is 6. 6 plus 1 is 7. All right, there we go. So we get negative 1, 7. And then that would mean that it's negative 3, 7 as well. And then when I plug in 0, that's going to be real easy. I'm just left with 1. Woo! It's a lot of mental math there. I think maybe we should have written that one down, but we nailed it, man. We nailed it. So 0, 1 is a point right there, and I can reflect that over my axis of symmetry, which I have not graphed. I'm going to leave it off of this one. Now I can go ahead and it's going to be dash or solid this time, actually. I almost said dash right off the bat. It is greater than or equal to, so this is going to be a solid graph. There we go. It can be hard to talk and graph on the screen. So I was silent, I concentrated, I focused. I feel pretty good about it. Now it comes to the shading. It's f of x is greater than. All right, that's going to be above the graph. So when I shade this, I'm going to be above, which would land on the outside, so to speak, of that parabola, right? And it does come all the way down there because really this graph continues. It continues to go forever and ever, right? It's going to continue down and down. It's just going to get steeper and steeper as it goes, right? But we always just graph it with the arrows, and that's about it. So I think that is a pretty solid graph of this quadratic inequality. I'm not going to worry about anything else there. We do have our y-intercept of 0, 1. I'm not going to deal with the x-intercepts. I think that's it. That's good enough. That's what I'm talking about.